computer. Okay. And that brings one other thought to mind. Okay, so I'm now recording, I hope. I press the record thing. Yes, I'm recording. But the other thing is, I'm teaching Math 121 from 9 to 10:30. And today's recording, I have to upload it to my computer. And it finished right at 11 o'clock. So if I happen to be, I'm going to ask a colleague if that can be downloading to my computer when I get onto our class. But if I can't, I might be 1 or 2 minutes late because my Math 121 recording is still uploading. So let me kind of reiterate. Rania asked if you'll be getting the notes. On Moodle, you'll be getting the notes and you'll be getting the recording. Okay?
Okay.
Okay. Lots of details to take care of right in the beginning of the semester. And also, always or never be concerned about asking me questions about things, or just like someone corrected me and making that -5. When we're in the classroom, I'm thinking about a lot of different things, but when we're doing this Zoom thing, I'm probably in more, my brain is going in many different directions, okay? So excuse me when I make errors, but please feel comfortable in asking me the question or saying, you know, would you please explain this, or whatever you need to, okay? Again, we worked together last semester. I'm hoping that you're all very comfortable with me and willing to help me out when I'm doing new things. Okay, so let's go back to that question. And the question is, what do you think about absolute value? What does it mean to you?
Isn't it like number is, it can't be a negative.
Okay.
Positive number, and it's like.
Would it be the whole?
The number is from the number.
Okay, so I'm hearing positive.
It's the value of the number regardless of it's positive or negative. So it is the value of the number itself.
Okay, does that capture what you're saying, Rania? So I heard positive, Rania.
Yeah, value of the number, disregarding the direction of it, maybe.
Okay, okay, so value of the number, disregarding the direction.
Yeah.
Okay. Any other thoughts? When I first learned it, I remember the teacher saying it was the distance a number is from 0 on the number line, right? So here we're thinking about number line, right? Ordinal value. Okay, ordinal number, remember that from the very beginning of whole numbers. We talked about ordinal number, number on the number line. And then we talked about cardinal number, how many things. Okay, so if we're thinking about number of things, we might need to think about a vector, which is an arrow with size and direction. Okay. And why don't we just leave it at that? But because we have these two characteristics, we have this idea of number line or direction on the number line. Okay, so we can think about absolute value as the distance a number is from 0 on the number line. Okay, we've got this number line from -10 to 10. And if we think about how many units is 5 from 0, our answer would be 5, right? We can write that question. Okay, this is our absolute value bars. The absolute value of 5 is 5. Okay, how many units is -5 from 0? Okay, -5 is 5 units from 0. What's the absolute value of -5? The absolute value of -5 is 5. Okay, I need to change the color on these, otherwise I get an accessibility thing. Okay, so let's look at the following questions. We want to find the absolute value of 7. So somewhere I've got my absolute, there it is. Absolute value of 7 equals 7. The absolute value of 8 equals, I'm sorry, the absolute value of -8 is 8. The absolute value of 0 is 0. And the absolute value of -3 is 3. Okay. Now, here we want to think about the absolute value algebraically. Okay, so this is a more sophisticated way of thinking about absolute value. And can someone give me these absolute values rather than me doing all of this?
0,
0, okay.
24,
24,
3,
3,
65,
65. Well, I better be careful here.
43, and then 15.
43. And 15. What do we notice?
All positive numbers.
They're all positive numbers. And so if we wanted to talk about how are the absolute values related to the number we were finding, okay, we can say that if x is positive, well, actually, if x is 0 or positive, then the absolute value of x is equal to itself. Okay, do we all agree to that?
Yeah.
Okay. So mathematically, okay, I'm going to even write it in more sophisticated, mathematically sophisticated language. Mathematically, we write the absolute value of x equals x for x greater than or equal to 0. Okay, the x is greater than or equal to 0 is this statement here, x is 0 or positive. Now let's consider, and maybe I should pause to make sure that that makes sense to you. Okay, here's where mathematics becomes like a foreign language, right? And it's something that it always took me a little bit of time to say, oh yeah, x is greater than or equal to 0. That means x is 0 or positive. Okay, could I have another person give me the answers here?
Would it be 10,
10,
24?
24. Is that Jamila?
Yeah,
Okay, thank you.
3,
3,
65,
65,
43,
43,
and 15.
43, and 15. Okay, look at all of those examples, and what do you notice?
The opposite of the number line. It went from a negative to a positive.
Goes from a negative to a positive. Goes. Okay, what operation can we perform on a number? So if I have negative 10, what can I do to that negative 10 to get it to be positive?
Multiply by negative 1.
Very nice. Okay, so what does that look like? Mathematically rewrite the absolute value of x equals the opposite of x. Notice I read it the opposite of x for x less than 0. Okay, let me write that out. The absolute value of x is equal to the opposite of x. I'm going to highlight that. I'm going to make it special. Okay, the opposite of x when x is less than 0. Okay. So notice we've got a number of different ways to think about taking the absolute value when we have a negative number, when the number is negative. So how do we write that? The absolute value function is a piecewise defined function. Okay, that's a pretty sophisticated mathematical idea. And what we mean by a piecewise defined function is that the function is defined differently for different intervals. Okay, in this instance, we have the absolute value of x is equal to the number itself, x, when x is greater than or equal to 0, but the absolute value of x is equal to its opposite when x is negative. Okay, so again, a very sophisticated definition for absolute value that we wouldn't share with kids, but for our own understanding, it's important. Okay. Okay, any questions on that? Okay.
I'm just trying to translate because I took pre-calc.
I'm sorry, Saba?
I'm trying to translate to I remember taking pre-calc and piecewise functions were in there, so it's basically the same thing, right?
It is, it's exactly the same thing.
I'm just trying to, to confirm.
Yeah. Okay, so we've talked about two important concepts. Okay, opposites and absolute value. Okay. When we talk about integers, and this is something certainly new to teaching mathematics that wasn't around in the dark ages when I learned this, we have different manipulatives that we use to represent numbers, okay? So we're going to use a plus sign, a positive, to represent a positive one, and a negative sign to represent a negative one, okay? So let's think about what would happen if we added a positive and negative. Okay, if you think back to a science class and you're thinking about atoms, right? An atom, A-T-O-M-S, right? Not A-D-A-M-S, okay? Atoms. We know that atoms have positive charges in their nucleus, and they have negative charges, negative electrons circling the nucleus, okay? And we know that when we have one negative and one positive, they neutralize each other, okay? Well, we're going to take this idea and we're going to use different language. We're going to note that one positive plus one negative is a zero pair. Okay, we're going to use that language, zero pair. This language is consistent with children's curriculum. So let's look at the different representations that I have here. We have 3 positives and 3 negatives. These, I guess, add to 0. We have 3 zero pairs. Okay. In example 2, what do we have? Oh, Yasmin, you're here. Hooray.
Yes, good morning.
Good morning, Yasmin.
So we have 4 zero pairs.
Right here,
We have 4 negative,
we have 4 negatives.
and to neutralize that, we'll have 4 positive.
Yeah.
And
Your audio is really hard to understand, Saba. I'm sorry. Okay. Let's look at number 3. Okay.
We have 2 zero pairs
We have 2 zero pairs
and positive 2.
and positive 2. So our amount is 2, or positive 2.
Mhm.
Okay.
We have 3 positive, 3 zero pairs.
3 zero pairs.
I can't count the minus 1, 2, 3. And I believe 4 negatives.
Yeah, it's kind of hard to count, isn't it?
Yeah, I
1,
think 4
2,
negatives.
3, 4, 5, 6, 7. Yes. We have 3 zero pairs
4 negative.
and 4 negative.
So it's negative 4.
So it's negative 4. Okay, so. Okay.
Dr. Zoft, if
Yes.
it wouldn't be too much to ask, can you explain number 1? How'd you get 3 zero? That's 3 zero pairs is from the 3 negative?
No, it's from combining a negative and a positive. So let me write
Is
that
what
out.
we're doing? Okay,
Okay.
that's what we're doing.
Okay, every time we, I guess, match one positive and one negative, we get a 0 pair.
Okay, I understand then. Thank you.
Okay, so think about this like the electrons in an atom, right?
Yeah, your parent, like one positive, one negative. Okay.
Yes. Every positive plus negative neutralizes each other. Okay, so we have +1 added, added to -1, we get 0. Let me put some parentheses around there so it's a clearer. +1 plus -1 equals 0. Is that better?
Yeah, thank you.
You're welcome. Thanks for asking me to make that clearer. I appreciate that. Okay.
I feel like this would be a good opportunity for like regrouping because I feel like this could be confusing.
Okay. Say more about that, Christina.
So like taking those and regrouping. So putting like a positive with a negative.
Mm-hmm. 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 So I had that, and I think I explained to you everything that we put on Moodle has to be accessible. And so actually, when you go into the textbook, you'll see this clearer. When I tried to draw circles and put the charged particles in the circles, I was getting accessibility issues. So I couldn't do it that way. I actually had to rewrite this document because when I did that, so if you can imagine, I'll try to do it now just as an example, but then I have to erase it. So let's suppose that I have, I need a text box.
No, yeah, just like with the kids, do you feel like that would be a good strategy to use with them, like to
Yes.
show them?
Absolutely. And even better, and I don't have them. So if you had colored chips, okay, so let me go back. And let's suppose, and we do have colored chips and we'll use those later, but suppose I had 2 yellows and then the red would be negative, okay? And then grouping 1 yellow, 1 negative, you get a 0. 1 yellow, 1 negative, you get a 0, okay? But I just typed that in and I got an accessibility issue, so I've got to get rid of it.
It's hard on here.
Another thing I'm thinking we could do like a one-to-one correspondence, like positives on top and negatives on the bottom, and then they can match one-to-one, and what's left is the actual answer.
Yes, wonderful. Okay, I'm gonna summarize these in words because I'm loving your ideas and I want you to have these ideas at your fingertips. So Christina, can you summarize your idea again?
That's basically what I was imagining, like a one-to-one correspondence.
Okay, but you said it differently, and it's important to say things differently because kids' ears are going to hear things differently. Okay, so can you?
I was imagining like a regrouping, so taking the positives and the negatives and you know, moving them, so one positive with one negative.
Does that summarize it?
Yep, perfect.
Okay, and then Rania?
Yeah, it's like one-to-one correspondence. We put positives on top and negatives on the bottom, and then we match it one-to-one. And what is left is actually the
Negative.
correct amount, like is the answer to the, you know, to the puzzle.
Okay, match.
Yeah, one-to-one correspondence.
Okay. Does anybody else have any other ideas?
It would be the same concept. It's just for me to better understand it, I just drew arrows.
Can you do it by using a number line?
Okay,
And then that's how
okay, and Jamila, that was you?
Yeah, I was wondering, can you do it as like in a number line or by using graphing of what's negative, like different colors,
Uh-huh, uh-huh.
like using different colors like of shades for the negatives and the positives, and then matching for each shade, like for each blue would be a red, and then whatever's left over is either positive or negative.
Yes, yes. Okay, so using all of these ideas for yourselves, I want you to find 2 ways to represent -3 using charged particles. Find 2 ways to represent 4 using charged particles. And then, let's see. If I put you in groups, then you lose this. So I'm just going to ask you to work independently for about 3 or 4 minutes. I'm going to pause the recording just so that there isn't this blank space on the recording. And we'll come back together. It's 11:57. We'll come back together about 3 minutes after 12. Quote a famous music group. You get by with a little help from your friends. Okay, good. Clearly I dated myself. So we want to add the following using charged particles. What did you do here?
it would be
I just did a number line, and then I put 2, like that, 2 loops, and then I did 3 more loops, which made it 5.
Okay, so use a number line.
Yeah.
Move 2 spaces, then 3 spaces. You end at +5. Okay. So now let's take this B. I guess I have to move this guy down. Oh, no, no, no. So B was -2 + 3. What can we do there?
I put 3 positive on top and 2 negative on the bottom.
1, 2, 3, and then 1, 2. Oops.
And match them up with like with an arrow, 1-to-1. I know it's hard to put this stuff in.
Well, it's hard to do it to begin with, but it's the requirements for this accessibility is making it very, very difficult.
Yeah.
So
So,
match up, yeah, one positive with one negative,
and the left would be a positive.
one positive
That's
left
it.
over.
This one.
Answer.
You could also use a number line for that as well, right?
Yes, you can. Oh, okay.
I set mine up just slightly different.
Go ahead.
So I just did my one-to-one correspondence and I wrote them like right underneath the numbers.
Mm-hmm.
So, like two negatives like on the left and on the right, like right underneath the -2 and right underneath the +3.
Mm-hmm.
Then you can just like circle them.
Mm-hmm.
Oh, you know,
And you didn't get an accessibility issue?
Much easier on paper,
Yeah.
but
Yeah,
visually it's kind of nice to see it that way on the paper.
it absolutely is. It absolutely is.
Zoff,
Yes.
I actually put, you know, those webs, like this, I did a circle and then I put two negatives and then I put the plus and then the web again and then three positives and then I just eliminated from there.
Okay. Okay, good, Arwa. That sounds great.
how about a
Okay.
diaphragm, I think, diagram.
A diagram. Mm-hmm. Okay, let's just do one more. Okay. I think the one after that was, I was just switching the negatives and positives. So the C was
2 plus -3.
thank you. Okay. And so we kind of have a similar situation, right? We would have two positives and, oh goodness, three negatives.
Yeah. But what's interesting, Dr. Zopp, is that when we do the one-to-one correspondence with the symbols for the
Yes.
negative and the positive, I think, in my opinion, that when you see the symbol itself and you put them next to each other, you don't get mixed up with the sign. So this one is a negative,
Uh-huh.
and then the first one was a positive. So you see what the sign is left, which one is left, and then you see, oh, it's a negative one, it's a negative, it's a positive one.
Mm-hmm. Mm-hmm.
Do you see where I'm going with this?
I see exactly what you're going.
So for me, I in my opinion, I think this is ideal for children.
You're absolutely right. It's not only ideal for children, but when I've used these positive and negative, like coins or manipulatives, I've had adult learners who could never get integers. It just pops into their head, and it's really a very rewarding experience to see people who have never been able to do this actually see it. I mean, and I mean the word see. They see what's happening. They see like the elimination. You know, every time I have a positive and negative, it neutralizes itself, and I'm left with. Okay, so it's powerful with young learners. It's powerful with adult learners. So take a moment or two to write a few sentences. What could you say if you were going to use these manipulatives to teach learners, and probably be doing this in fifth or sixth grade? What rules might you create using these manipulatives for adding positive and negative numbers.
I actually going for preschool and kindergarten. I feel that you can use like counting bears, different colored counting bears,
Mm-hmm,
and they can match up a red with a blue,
mm-hmm,
and then whatever is left would be a negative.
mm-hmm. You're right. I'm just giving you a minute or two to jot down some ideas. While you're doing that, I'm going to go through, is Zainab Abdul Jabbar here?
I contacted her and she said she just dropped the class because it conflicted with one of her other classes.
Okay, thank you.
And yeah, so I guess that's why she wanted it, but
Okay,
yeah.
thank you.
You're welcome.
Is Reem here? Okay. Okay. Thank you. So what do we want to write here?
I wrote when representing numbers using the charged particle language. As educators, we can use many ways to translate the idea to children by number line, where we start at the number and then we move 2 spaces either to the right or to the left, whether the sign is adding or subtracting.
Mhm.
And then the end point is the number that we're representing. Or we can do the one-to-one correspondence, where we match up a positive and a negative, and then whatever is left over with the sign itself is the number. So how many ever are left, and then that's the charge, like the sign, either positive or negative. I hope that was helpful. I don't know, in my mind, it made sense.
We're just going to stay with the charged particles.
Yeah.
I just like in between, I found it easier if we say like each positive charge particle deletes a corresponding negative charge particle, like somewhere in there, you know.
Say that one more time, Rania.
Like each positive charge particle deletes a corresponding negative charge particle. Delete, yeah, negative charge, or a correspondent negative charge particle.
At least one negative charge particle. I'm not sure where that corresponds to, goes in. Each charge particle corresponds to one charge particle?
Like, no, delete one correspond negative charge particle, like somewhere in the center.
Yeah.
Like just to make it easier for kids to understand, you know, I don't know. Like using a simple language, you know.
Okay, any other thoughts?
Dr. Zaba, what I use with the example I use with my children
Uh-huh.
is that if you playing a game and you like, for example, you lost 4 points and you gain 3 points, that means you lost 1 point. It's all about lost and gain.
Okay, so you still have a loss of 2 points, right?
Yes.
Yeah. Okay. So let's shift to the number line model. Jamila has already had us work with the number line model. We've got a number line going from -10 to +10, and we would work, I think Jamila's used the word hopping, right? We would put 0 somewhere, and for that first problem, we would hop 1, 2. At that 2, we would hop 3 more, 1, 2, 3, and we find that our answer is 5. Okay, so begin at 0, move 2 places right, then move 3 places right, beginning at the 2. And you have to be careful to realize that. I've had adult learners, especially when I'm working with graphing, who will start at the 0, move 2, 1, 2, then they go back to the 0 and do the 1, 2, 3. So you have to be really specific that you're going from 0, you're moving 2, and then you're moving from that 2, 3 more. 1, 2, 3. Okay, that might seem obvious to us, but it's not always obvious. So make sure that you're including those itty bitty details. Okay. What would happen with, oh goodness. No. What would happen with our next problem? So we've got -2 plus 3. What are we going to do on our number line?
We would begin at 0, move 2 places to the left, and then move 3 places to the right, starting at -2.
Beginning at -2.
Yeah.
Move 3 places right. Okay. We end at +1. Okay.
So you always start with the negative number first, and then you go down to the positive?
No. The only reason we started with the negative number there, Jamila, was because it was the first addend. Whoa.
Okay.
Okay. So see, it's -2. That's I'm starting there. Begin at 0, move 2 places left because that's our first addend.
You go with the
But
first number.
Saba, she started with 0. She didn't
Okay.
start with the -2, right, Saba?
Right. We start with 0.
Yeah, you start with, that's what I heard.
Yeah. So think about the next problem. The next problem, all that I did was I changed the signs, right? So we're going to begin at 0. We're going to move now 2 places right. Okay. Then beginning at +2, move 3 places left because of the negative.
Yeah.
We
3
end
places
at,
to the right. Okay.
okay, does that make sense?
Yeah.
Yes.
Okay, do D, E, and F for yourself, writing out those little details.
Grab a piece of paper.
Dr. Zuff, do we have to use a number line or is that just like optional?
No, for this particular part, remember in the beginning, we started using the charged particles. Now in this section, we're using number line. So yes, please use number line.
Oh, okay, thank you.
For number C, why we're moving two places, right? If we want to end up at -1 away from 0, isn't it 1?
Well, remember, Rania, that we're starting at 0. This
Yeah.
2 says we go 2 places right. Then the -3 says 3 places left.
Oh, okay. We're just writing the steps one by one. Got it.
Correct,
I just
correct.
I'm jumping from 0 to okay, got it. Yeah.
Yes, yes.
Rania, if you number line, if you number the number line, it makes it really easier.
Yeah, I got it. I just missed the part because I left my daughter wanted something and I had to come back. So
Okay.
yeah, I got it. We're going one by one. Yeah.
Yeah, the 2 is to the positive because it's positive, so it's to the right, and then left is always negative.
Thank you.
Okay, any questions?
No, it was fairly basic, honestly.
Okay. We're going to write an algorithm on Tuesday. Make sure you go to Moodle to look at the assignments. Let me know if you have any questions.
Okay.
Okay.
So you don't want us to write a summary, or do you?
I
is it
do,
okay?
yes.
Oh,
Do you want to do it right now? We can do it right now.
I already started, so I was just wondering. I don't want to write something and then it turns out to be incorrect. That's all.
Okay, so what do we notice when we add two numbers that have the same size sign?
Mm. Yes.
So if we add +5 and +2.
0.
Okay.
No,
A
+5 and
a
+2, we
positive
get
number?
7.
Yeah, we get a positive number.
What happens when we add -2 plus -5?
We also get a positive number.
No,
Oh, wait, oh,
-2.
we,
You'll have a negative integer.
You have a negative integer. So when we add two numbers that have the same sign, we add the numbers and attach the common sign.
So we
Right.
end up with the same sign at the end.
Right.
okay.
What happens when we add numbers with different signs?
We end up with the sign of the bigger number.
Yeah,
Yeah, the larger value.
we
Yeah.
subtract the, and I should say absolute value of the numbers and attach the sign
See, they called me out.
of the greater number when the signs are ignored or when we have the absolute value. So when we have the same sign, we're adding. When we have different signs, we subtract.
Yeah.
And
I
then
feel
we have,
like,
go ahead, Saba.
so I was writing that when we're representing addition and subtraction on the number line
Mhm.
model, that it's a nice way for the students to visualize the math problem.
Mhm.
Like, I think it's a good way just for dealing with negatives, even for me. Like,
Mhm. Mhm. I agree with you. Okay. Well, hopefully this was a good class for you. I will be uploading the recording on Moodle sometime this afternoon. It takes a while for it to upload. And then I will be saving this document and sending the document out to you as well. Okay. Oops.
okay.
Okay.
So for the Wayne State paper that you sent for 5.1, are we to start on it?
You could. Don't get upset about it if you don't.
It's not due next Thursday.
It's not due next Thursday. Okay.
Okay.
The assignment due on, I think, August, there's one due on August 30th, 31st.
Is there? I
Do
need
we
to
have
check.
to type it
It's
out?
the Wayne State paper.
Oh, you know what? We didn't get started on that, so don't worry about that yet. Okay.
Okay, so we don't have anything then for this.
No, Uh-uh. Just
Oh,
read 5.1, okay?
thank you.
You're welcome.
Okay.
Everybody have a great day,
Thank you so much.
and we'll see you on Tuesday.
Hey, Dr. Zoff,
Yes,
do you have like 2 minutes?
I do.
After everyone jumps off? I just have a personal question.
okay,
So we should go online at 11 Tuesday?
11.
yes.
Okay.
Okay.
All right. I'm leaving. Bye. Enjoy your
Bye.
day.
Dr. Zoff, I just want to make sure that you got me. I know I kind of came in
I
like
did. Yes, I
last
got you.
second. Okay. I was
Okay.
working. I'm sorry.
That's okay.
Okay. Thank you.
You're welcome.
Bye.
Bye-bye.
Bye. Thank you.
Bye-bye. Have a good weekend.
You too. Thank you.
Hey, Dr. Zoff, I just had a quick question. I know you mentioned earlier when we were talking about the syllabus that you will be posting these videos when you record them. If we by chance do miss a class, we're able to visit those videos later on, write a brief summary, and just shoot that in an email over to you.
Yes.
Yeah, I just have my work schedule is switched up and it's kind of tight right now. So on Thursdays, I might not always be available. I certainly will afterwards,
Okay.
It won't be an issue at all. I will check in. I just might not be live
Okay.
on some Thursdays. And I just want to double check that was okay.
Okay. And if you just check in with me, Jessica.
Yeah.
Okay.
Awesome. Thank
Okay.
you so much.
You're very welcome.
Have a good day.
Take care now.
Bye.
Bye-bye.